Hi, my name is Logan Kramer, and I lead the Lehigh University Autonomous Underwater Drone Team, or Lehigh Underwater Robotics for short. We are here today to present to you our competition strategies for our autonomous drone Osprey. Our overall goal is to design, build, and program an autonomous underwater drone with the help of Lehigh University that can be used for multiple applications such as underwater research and data collection, while designing a drone that can be improved upon by Lehigh students in future RoboSub competitions. We also aim to explore research topics including underwater acoustic wireless communication, simultaneous localization and mapping, or SLAM, and methods for PWM motor control, which we can then implement into our drone.
For this year's RoboSub competition, we are planning to complete several of the tasks. We are focusing on having Osprey participate in the Choose Your Shootout gate task, survive the shootout torpedo task, and make the grade buoy task. We plan on participating in more tasks in the future. However, we are focusing on these 3 tasks because this is our first year entering the competition. We are prioritizing designing and building a viable underwater drone that can be improved upon in the coming years. We are also researching and designing effective SLAM, simultaneous localization, and mapping algorithms to achieve real-time processing of underwater videos. Since there were no specific point values given for the tasks, we prioritize them based on feasibility and compatibility with our current mechanical design, as well as electronics and software capabilities. The gate task is our top priority because visual recognition was the primary focus of our software research over the past year. The next task we focus on is the buoy task, for the same reason as the gate. Our research focuses on visual processing of underwater camera footage, and these 2 tasks focus on processing camera information and having the AVU react and move based on what it sees. The third task we focused on is the torpedo task, survive the shootout. This task requires the drone to see the 2 images in the water, then locate the holes in the image and fire a torpedo through one of the openings. This task will rely on similar code as the other 2 tasks, but it requires an extra subassembly on our drone. Our initial design did not include the torpedo subassembly, so this task is the lowest priority for us out of the tasks we plan to complete. Our main focus involves getting a drone that is easily maneuverable so our software team could use it for coding and camera testing.
Osprey was designed to have a wide camera view while being compact as possible. We wanted a small, highly maneuverable, and modular drone for this competition. We decided to design the hardware using an NVIDIA Jetson Xavier NX connected to the PixHawk 4 flight controller in the main watertight tube. We have 2 batteries stored in the smaller 2 tubes on either side of the drone. We made the drone out of a lightweight marine plastic and carbon fiber tubing to increase buoyancy. Should the design be too buoyant, we plan to add more weight to the drone.
Hello, my name is Olivia. I am the team leader for the electrical sub-team on Lehigh Underwater Robotics. Our team has run into many obstacles while building, programming, and wiring our drone. After creating our power distribution configuration, we were able to easily condense it inside the watertight tube that houses our hardware. Once this was finished, we had to begin wiring up the other components such as the thrusters and other sensors. Unfortunately, we ran into an issue with the compatibility of our sensors with our flight controller. Our depth and leak sensors were not properly communicating via the MAVLink protocol, which is concerning since the leak sensor is crucial to the protection of our components and the depth sensor provides valuable navigational data. We are continuing to work with interfacing the leak sensor with the PixHawk, and as for the depth sensor, we decided to try and implement the Blue Robotics ping sonar instead, which not only provides depth measurements, but also object recognition data. We hope that this change in design will ultimately allow our AUV to better navigate through each task.
Hi, I'm Jun Chen, and I'm the leader of the software sub-team. We have done most of our testing so far using different underwater vehicle, the Blue Robotics, also known as Blue ROV2, in order to gather data and import information to help our programming team while Osprey is being built. Those tests including build a replica of the Choose Your Set gate event and control a different AUV with a camera to record videos, so our programming team can work on making an image recognition algorithm so the drone can identify the different gate. We also has drone camera and distance testing, so Osprey can not only identify object, but also calculate the distance to the object. The video shows the blue ROV in the water using version and distance tracking software our team developed last year to detect a bucket and implement an automatic emergent brake.
Thank you for watching our video. See you at RoboSub 2022. Gracias por ver nuestro video. Nos vemos en RoboSub 2022.
感谢您观看我们的视频，让我们在 RoboSub 2020年的比赛上见面。